Hello there. Today we'll be doing combination sum, 75th problem. We're halfway there. Uh, I am rushing a little bit. We need to get through these problems so that we can get through more problems. That is going to be on my interview soon. So here we go. So combination sum 2 is a problem where we will be given candidates and targets, but we can only use the candidates once. So we're going to use a decision tree again to select our items, and we'll use what we learned previously so that we can skip the same item because we don't want to use the same item more than once, or not more than once, to have a branch of our decision tree that uses the problem more than that uses that particular item. Again, here's what I mean. So let's say we sort these items like sum. So instead we get 1, 1, 2, 5, 6, and 10. So first things first, we choose a 1 or not 1, and then on the 1 section, then we can choose to have a 1 or not a 1. But on the empty side, we don't get to, once we have left the ones, we're not going to be appending any more ones. We're just going to start with 2s. That way we skip that altogether. So we have a 2 or blank. So now what happens here is that we have a 1, 1 or just a 1. That's what I mean here. Anyways, so this one will can no longer make 1s. So we start to 2, and the same decision tree process. Then this one takes a 2, 1, 1, 2, like so on and so forth, like our usual decision trees, or 1, 1, and nothing. So, and this is going to just take a single 1 and skip, and this is going to take a 1, 2, and so on and so forth. So if you have any questions, please check subset 2 for more information about how we're doing this. But this is the general pattern that we'll be going through. This is going to be unlike the way Neetcode's doing it, but this relies on the same structure that we learned in the first couple previous problems, and this is going to build on top of that. So this is basically, if you take a look at the code of my combination sum, this is basically the same code. But we're going to change the names a little bit to suit the problem a little bit more now that I've learned a little bit more about backtracking. And we're going to have the subset in some in our function. So if a current sum is equal to the target, then results.append. This is what I've learned recently, so we're going to do that. And return. These are all the tricks that will make the code run a little bit faster. So we're learning a bunch of tricks, and we're combining them together, which is great. So if it's greater than or length of target, or the current sum is greater than the target, let's return. Otherwise, this is all of the possible options. I like this type of code because it expresses to the reader that, hey, we're going to do these things, and if it hits any of these conditions, we're going to return. And if it doesn't hit these return conditions, we're going to keep going. And it just makes it clear to the next reader that here's what we're going to do. It's either this, that, or the other thing. That's it. Okay, so if we're under a target, let's keep adding to candidates. And if we're over a target, let's just quit. If it is the target, get the item into our results, and then just skip. So DFS, not DFS, backtrack. We're gonna backtrack I plus 1. This basically means that we're gonna keep getting new items. as we like move forward until we're just grabbing every single item. This is going down the left branch of the tree. And subset. So then what happens is that after all of this, we return. We're done with the item. We're done with the ones. So what we want to do now, like we said earlier, we're skipping all the ones. We're no longer looking at all the ones anymore, because we have done that. So length of candidates and candidates. You can see this is very similar to my previous code in subset 2. So this is where we will be skipping the item. So let's run through the code a little bit, and I'll show you a little bit more. So then we'll do subset.pop. So this here .pop removes the item that we are looking at. So in this case, we are removing the 1. So we only have a single 1 now, and we have already skipped all the other ones, so we cannot add any more 1s. So anyways, subset.pop, and we do a backtrack. So each backtrack brings us to a special answer, a new answer, and that's pretty cool. So sum plus candidates I and subset. Yeah, to include or not include is here, and we include the next one. So that's it. And yeah, okay. Anyways, with that, I think we're done. Let's return our results. Oh wait, we didn't actually call backtracking. My bad. Zero, start with 0, and let's have an empty subset. Again, this is just for speeding up the candidates not found. Spelled that wrong. Oh, wrong answer. Weird. Let's see what's going on here. Interesting. This is what's wrong. We skipped something, but we're adding it. So that was my bad. So in this particular situation here is that we are skipping the item and we're moving forward with the next item. So submit. Yeah, pretty good. So this was much faster than my previous one, which was accepted, but it looks a little different. Of course, it has the old code. I was, testing that out. Anyways, I hope you learned something today. What we learned today was that we were combining the 2 different problems, which we did really recently, subsets, where we are doing this particular situation where we are skipping the item, and we are combining that with this particular problem here, combination sum. And as you can see, the code is very much similar. This particular code, the basics is that we continue getting the same candidate over and over again, but instead we're getting the next candidate because we can't use the same candidate twice. And this particular pop here is skips the item that we want to skip, so that we can try something else. We can try the 1, and then we can try the 2, and then try 3. So this is where we're skipping the first item or any thereafter item, like in between. So that's how that is done. So if you want to know how Neetcode does it, you should check that out. But I'm going to be keeping it simple and learning it with one method for now, and keeping it a general pattern that I can use, because my interview is coming up really soon, and I don't want to break the mold yet. Of course, learning other methods of doing it is great, but I need to get this pattern fixed in my brain first. So I'm keeping at it, and we have solved this particular problem with a pretty fast time. And what's happening now is that let's print out the results every time, and let's see what's going on. How we're building this particular item. So we started with nothing, and then we built up a 116, a 125, and a 17. So this suggests to me that we were throwing in the 1, then we threw in the 1 again, and then we moved on to the 2, and then we tried the 5, and it was over. So we just tried the 5, and then the 6, it was over, and then we tried the 6, and that worked. So we returned, and then we tried the 10 afterwards, after, you know, returning and popping and backtracking, and we tried the 10, and it didn't work, of course, and then we backtracked some more. So we kept on backtracking, popping, backtracking, until we had a single 1 at that point, because we're skipping that for now, and we did I+1, skipping it over, and we got the 2, and we tried the 5, and we got 8, and of course we tried once we hit 8, we stopped, and then we tried 2 and 6, 2 and 10, then we stopped, and then 1, 5 and 6, and then 5 and 10. Then we finished the 1s, and we moved across. We're not starting with 1 ever again, right? And then we started with 2, and therefore and thereafter, yeah. So that's how we did this particular problem. Very good. Oh, that's funny. I forgot to put 7 in here. But that's how the algorithm goes. I hope you learned something today. And if you enjoyed the video, like and subscribe. And if you want more, check the link in the description below. I will be updating the list shortly, depending on when you see this video. The list in my link in the description below will be updated. Thank you very much, and I'll see you in the next one.